Hi, this is John Carlisle. It's my great pleasure to welcome you to the first LEEP Summit. Let me hear it. Yeah, we're live here in Chicago, Argonne in Chicago, actually. We have an incredible lineup for you today. It's 26 LEEP startups representing not only the graduating fellows for the program, but also alumni of the program that are starting to actually drive products into the market. We'll also celebrate the founding of a new LEEP node at the National Renewable Energy Lab, Westgate, and enjoy presentations from their founding cohort, who of course are just getting started. We'll also have a very important panel discussion focused on inclusive innovation, so please stay for that as well. So of course we wanted to do a big in-person event. We were going to be downtown in the Sheraton with 300 people. It would have been great, but as all of you know, COVID continues to make it hard to get back to normal, whatever that's going to be. So almost 2 years ago, we did an event where we really committed not just to doing another boring Zoom call. And we've done that again here. We've opted to go to a unique, true hybrid event with 4 live venues, including the one here in Chicago, but also in Colorado, in California, in Tennessee. And we're intermixing live in-person content with live remote presentations as well as pre-recorded segments. I hope you enjoy the show. Big shout out to our sponsors. Constellation is an overall event sponsor. World Business Chicago is putting on the reception following the event here. Axion is sponsoring the Inclusive Innovation Panel. Meatyfoods, CRI Cohort 1, is here with some of their animal-free Nashville hot sandwiches for everybody who stays. If you're local, you still have a chance to come. Yeah. New Mexico LEEP. There's LEEP nodes everywhere now. One of them in New Mexico, we'll hear about that, but they're also a sponsor. And then most importantly, the Advanced Manufacturing Office at DOE. They are the primary sponsor of the LEEP program itself, and of course they provide a lot of support, labs too. So, what is LEEP, you ask? LEEP stands for Lab Embedded Entrepreneurship Program. But if you're around LEEP any period of time, you quickly realize it's a program that's very hard to sum up in just one sentence. Our opening session features a series of welcoming remarks that will address this question from different perspectives, from the Department of Energy leadership, from our ecosystem partners, the national labs themselves, as well as the private sector. And then after that, I'll wrap things up with my own perspectives as the former director of the Chain Reaction Program here in Chicago. To start, it's my great honor to introduce Jennifer Granholm, U.S. Secretary of Energy, for her welcoming remarks and thoughts about LEEP.
Hello everyone, I'm Secretary of Energy Jennifer Granholm. Thrilled to welcome you, the next generation of energy entrepreneurs, to this first ever Lab Embedded Entrepreneurship Program Summit. I know we had all hoped to be together in person for this summit, but safety is a top priority for us at the Department of Energy. And over the last 2 years, we've come up with some of our best ideas while we've been at home in our pajamas. So first off, I'd like to say hello to our phenomenal lab staff who are participating in today's summit. And of course, to all the scientists and entrepreneurs who are ready to be inspired and to get to work on the next breakthrough. We're here today because we know that scientific discovery and entrepreneurship actually go hand in hand. Since 2015, this entrepreneurship program has brought those two together. The Lab Embedded Entrepreneurship Program gives bold entrepreneurs a 2-year runway at a critical early stage for their ideas to take flight. And through the program, we've actually connected dozens of innovators to some of DOE's best and brightest at Argonne, at Lawrence Berkeley, and at Oak Ridge National Labs. And today, I'm really thrilled to share that the National Renewable Energy Lab in Golden, Colorado has just joined the team, making it the 4th national lab location where entrepreneurs can go to turn their big idea into the next big thing. These entrepreneurs, they get training, they get technical resources, they get mentorship, as they develop next generation technologies that are going to pave the way to a better future. And in turn, we get to grow the ranks of clean energy change agents who are transforming the country. Over the past 7 years, this fellowship program has served as an incubator for about 120 startup founders. And that includes Grayson Zoloff, who was in the 2020 cohort at Lawrence Berkeley's Cyclotron Road, and Megan O'Connor, who worked with folks at Oak Ridge's Innovation Crossroads. So Grayson went on to co-found a company focused on wireless charging for medical devices implanted in the human body. And that raised more than $9 million in a seed round this past February. And Megan started with Nth Cycle, which is based on a recycling technology that extracts critical metals from batteries and waste and other materials that we can reuse to make new clean energy projects. So Nth Cycle got nearly $1 million from the National Science Foundation to continue her partnership with Oak Ridge. And that partnership, of course, is on electrochemical recycling technology for recovery of critical battery cathode materials. So to date, Grayson and Megan and their fellow program entrepreneurs have collectively attracted $918 million in follow-on funding for their startups. They've created 1,000 jobs, and at least 14 of these companies have started building production facilities and started shipping products across the country. So exciting. Those results show us the incredible power that government and the private sector can wield when they come together to scale new technologies. And that's a big reason why I'm so bullish about the future of this program. I think we can innovate our way to solutions, both large and small, solutions that will turn the tide against climate change, that will make clean energy more affordable and more accessible, solutions that will make our energy system more resilient, and honestly, make our country more secure and our economy stronger and more equitable than ever. And that's why I want to see this program grow. So if you're an entrepreneur with a great idea for a groundbreaking product, apply to join the next cohort. And if you're an investor looking to put your capital behind new opportunities, take a good look at these program fellows. And if you're looking for a job in clean energy, check out the businesses coming out of this program. If you're representing a university, if you're representing a business, talk to us about how you can replicate the entrepreneurship program model. And to all of you, thank you so much once again for taking part today. Enjoy the summit.
Now I'd like to introduce Kelly Speaks-Bachman, Principal Deputy Assistant Secretary for the Office of Energy Efficiency and Renewable Energy at the DOE. The Advanced Manufacturing Office that supports LEEP sits within Kelly's office at DOE. Take it away, Kelly.
Hello, and thank you and welcome to everyone who joined us today for the Lab Embedded Entrepreneurship Program Summit. At DOE, we are laser focused on equitably transitioning the United States to a clean energy economy by 2050. Meeting the challenge of net zero carbon emissions requires moving clean energy innovations out of the lab and into the marketplace more rapidly than ever before. And this Lab Embedded Entrepreneurship Program does this by leveraging national lab expertise and facilities and networks, and by aiding entrepreneurs in the development of clean energy technologies and innovations. The technologies and solutions that come out of this program accelerate our transition to reduce emissions. Now, the department has also broadened our focus to go way beyond just clean energy R&D. We know that we can't transition to a clean energy economy without bringing communities and workers along with us. And so to ensure that we're doing that, the Office of Energy Efficiency and Renewable Energy established 4 guiding principles. 1, institutionalizing energy equity and environmental justice. 2, ensuring diversity and inclusion in STEM. 3, developing a skilled clean energy workforce. And 4, strengthening engagement with state, local, and community partners. This is where the Lab Embedded Entrepreneurship Program shines. Instead of funding the technology, this program funds innovators with promising ideas to make the world a better place. And we're supporting the training and education of the next generation of clean energy pioneers and providing the tools that they might need to help grow their businesses. So as we prepare the clean energy workforce for the future, we need to be ensuring that we're employing a workforce that's diverse and inclusive, one that looks like America, quite frankly. Creating partnerships that bring diversity of thought from various communities to the table. That's the only way we're going to be able to solve the energy challenges that we have and the climate imperatives that face us as a nation. So through this lab-embedded entrepreneurship program, we're empowering a diverse and skilled group of innovators. The program also supports the energy, equity, and environmental justice goals that we've set out for ourselves. Entrepreneurs are developing clean energy solutions to reduce pollutants and toxic materials that disproportionately harm low-income households and communities of color. And finally, by investing in innovators, we're embedding their businesses and solutions into communities across the United States. This program is a model for clean technology innovation investments across DOE, across other government agencies, and industry partners. These entrepreneurs are helping to build a clean energy future. It's going to create a good paying jobs, it's going to lower energy bills for everyone, and it's going to support a path towards US energy independence. So lastly, I'd be remiss if I didn't take the time to thank John Carlisle, who, as the founding director, helped launch Argonne's chain reaction innovations and carefully nurtured this program and mentored innovators for more than 5 years. John's going to retire following the summit, and I just wanted to thank him and to recognize him for his tireless work, for his passion for the lab-embedded entrepreneurship program itself, and for his steadfast belief that the national labs and Department of Energy can improve lives and address climate change. So thank you so much for your service, John. And thank you to all the innovators and the investors and the industrial partners who've joined us today to learn more about the lab-embedded entrepreneurship program and to connect with those who share your energy goals. We believe strongly that together we can ensure this clean energy future for ourselves. So thank you.
Well, thanks, Kelly, for your very kind remarks. It's been an honor and a pleasure. And thanks again for the support of your office at DOE, the Advanced Manufacturing Office, for supporting LEEP over the last 7 years. So that's the perspective from the government. Let's turn our attention to a key ecosystem partner for CRI. Now I'd like to introduce Juan DePablo, Executive Vice President for Science, Innovation, National Laboratories, and Global Initiatives at the University of Chicago. Since CRI started, we had worked extensively with the University of Chicago, the Polsky Center on Entrepreneurship, the Booth School of Business. They have provided extensive business training and mentorship for our innovators. So thanks a lot, Juan, and I'll turn it over to you. This is part of our live part of the show here. So,
thank you very much, John. It is a true pleasure to be here. Good afternoon. I'm Juan DePablo. And as John pointed out, I'm the Executive Vice President for Science, Innovation, National Labs, and Global Initiatives at the University of Chicago. I believe strongly that innovation is key to our future. So it is my great pleasure to join you at this Lab-Embedded Entrepreneurship Summit. Today's event brings together 4 national laboratories that have LEEP programs, essential innovation in action. It is particularly exciting because my role at the university is really to forge connections and create partnerships that nurture innovation. The University of Chicago has a very special relationship with Argonne. Through UChicago Argonne LLC, it brings the best commercial practices and marshals the talent that is needed to lead innovation into the future. Chain Reaction Innovations, the entrepreneurship program at Argonne, is an example of this, showcasing the path to public-private partnerships so that innovation, science remain at the forefront of our mission. The need for partnerships like these is clear. Working together, we can address the most pressing problems in science and technology. And of course, the perfect example of this is climate change. In fact, the startups that you're going to see here today focus on clean energy solutions. They're particularly promising innovators who've been chosen to move their science forward with the support of a national laboratory. Programs like LEEP provide the framework for these partnerships. The University of Chicago is particularly proud to partner with Argonne and Fermilab to support collaborations. Through them, we create strong ties not only in our ecosystem, but relationships that ripple across the region and across the nation, maybe even the world. You'll see these and much more today. I should mention that the university has a unique relationship with Chain Reaction Innovations. Two of the startups pitching here today, QDIR and Super.tech, spawn their technologies out of their PhD studies at the University of Chicago. Our university is very pleased to be an integral part of this innovation ecosystem through both scholarship and research. Working together, we can expand the reach of science and technology. And at the same time, we're paving the way for another generation of entrepreneurs and companies that will generate equitable economic opportunities for our communities. Thank you, Argonne, for helping to convene this forum. And thank you everyone for attending and helping us envision a brighter future. John?
Thank you so much, Juan. Thank you, Juan. Thanks again to the University of Chicago for all their support, CRI, over the years. Now I'd like to introduce Paul Kearns, Director of Argonne National Lab, which is located here in Chicagoland, about 25 miles away, the main campus. This is Argonne in Chicago here. Paul, it's one of the cool things about CRI that it derives its name from the way Argonne was set up and founded. And in many ways, Argonne itself was a spin-in of an innovator wanting to develop a high-risk energy technology, atomic energy at the time. So anyways, welcome.
Thank you very much, John. Yeah, how fantastic, really. Let me add my welcome to the Department of Energy's first Lab-Embedded Entrepreneurship Program Summit. It is wonderful to be hosting today's summit in person here at Argonne's Chicago location and virtually with 3 other national laboratories, Lawrence Berkeley, Oak Ridge, and NREL. It is certainly a pleasure to be with you all today. Let me start by saying congratulations to our innovators from across the 4 LEEP nodes. You're doing incredibly important work and making an impact with your technologies. LEEP is a prime example of how the national laboratories can partner with innovators and companies to translate early-stage technologies into real-world solutions. Let me say, on behalf of Argonne, it is an honor to be part of the LEEP program and to have the opportunity to support the best and the brightest science and hard tech innovators the U.S. has to offer. As you may know, Chain Reaction Innovations, or CRI, is the LEEP node, as John just mentioned, here at the Argonne National Laboratory that supports the development of a range of technologies and companies that are helping to accelerate the clean energy economy and forge industries of the future that will secure our nation's economic competitiveness. CRI innovators are developing heavy-duty engines to run on renewable plant-based fuels. They are also enabling more energy-efficient data centers and numerous inventions in between. Indeed, CRI has become a magnet, drawing some of the most promising innovators to the Chicago area. Many are putting down roots and building facilities here in the region. Argonne's participation in LEEP has not only benefited the startups with whom we're working, it is also benefiting the laboratory, multiplying collaborations between entrepreneurs and our scientists. In the 6 years since the program launched, CRI has supported 35 innovators, and those innovators have raised $209 million in funding. The companies have established and have created more than 262 jobs, really fantastic in that regard. Their impact is remarkable, and we look forward to seeing what comes next from these exceptionally talented individuals. I also want to note that CRI strongly supports diversity, equity, and inclusion. We are intentional about inclusive messaging when we recruit our innovators. From diverse universities to colleges, our outreach program is active. We also focus on unconscious bias training for our pitch competition judges. We are taking steps to ensure we are inclusive. The data tells us that our approach is working. 50% of our startup founders who have gone through CRI are from underrepresented groups, and 31% are women. We've also launched a new internship program, which we call SEED, to give Chicago area college students from under-researched communities the opportunity to work side by side with CRI innovators and empower them to pursue and excel in STEM careers. With more diverse ideas and backgrounds, we are fueling dynamic collaborations and transformative innovations. Our future success depends on this effort. We are pleased to be moving in the right direction. Congratulations again to the innovators from all our LEEP nodes. Let me extend my thanks to the Department of Energy's Advanced Manufacturing Office for their vision, leadership, and support of the LEEP program. I would also like to extend my thanks to Secretary Granholm, Director Shalonda Baker, Principal Deputy Assistant Secretary Kelly Speaks-Backman, and the Office of Energy Efficiency and Renewable Energy for participating in today's summit. LEEP simply would not be possible without their support. Finally, just like Kelly, I would like to recognize John Carlin today. He's moving into the role of CRI Senior Advisor, and certainly want to acknowledge his great effort to really organize our activities today. I also want to more broadly recognize those really supporting our activities today and the sister labs who are hosting this summit with us. Your hard work and dedication are really commendable. Please enjoy today's event, which will showcase new technologies and systems that will go a long way towards shaping a better tomorrow. Thank you for helping us open new frontiers for America's energy future. Thank you.
Thank you, Paul.
Thank you. Thank you.
So that's the government's perspective, that's the National Lab's perspective, the ecosystem. Now let's get the private sector's perspective. I'd like to introduce Eric Toons, who is the Executive Managing Director and Technology Lead of Breakthrough Energy Ventures. Eric has served on the advisory councils for two of the LEEP nodes, Cyclotron Road and CRI. Breakthrough Energy is also an investor in several LEEP startups. Breakthrough Energy is also working on a number of fronts to support innovations addressing climate change, in part with the Department of Energy. Eric, take it away.
Thanks very much, John, and I'd certainly like to congratulate you on your retirement, but thank you for all that you've done to make CRI so successful over the years. In 2015 in Paris, the leaders of the OECD world announced mission innovation and an ambitious plan to double their country's R&D expenditures by the end of the decade, by 2020. At the same time and on the same stage, Bill Gates announced the formation of the Breakthrough Energy Coalition, a group of 35 of the world's wealthiest and most influential individuals that was designed to be a private sector counterpart to the public sector mission innovation. In 2016, they announced the first activity of that group would be the formation of Breakthrough Energy Ventures, a clean tech fund that was built different by design, built based on the lessons of Clean Tech 1.0 that happened in the first decade of this century, and was designed to be to avoid the pitfalls, or at least some of the pitfalls that effort ran into. Today, Breakthrough Energy Ventures has invested out of multiple funds and has 100 companies across all 5 of the areas in which we're active: electricity, transportation, buildings, manufacturing, and agriculture. And we're raising multiple new funds to build on the success of the past 5 years. Earlier this year, a merger with Breakthrough Energy, originally devised as the nonprofit part of the Breakthrough Energy Coalition, sort of completed this effort and created unprecedented opportunities. And we now have a single staff of well over 100 people overseeing every aspect of translation, from the various earliest stages of inception all the way through to late stage project finance and deployment at scale. And as part of that, we have our own LEEP program, the Fellows Program, that has worked closely with John and other members of the Department of Energy effort. We also have a suite of ancillary capabilities that can work with our portfolio companies, including Policy Engagement, a group in Washington, also a group in Europe, as well as media outreach. LEEP and programs like LEEP are an absolutely critical component of the value chain. The critical message of Clean Tech 1.0 was that advanced deployment of technologies in tough tech generally, and in clean tech in particular, work very differently than technologies expand in tech. And mapping the tech model of investment straight onto clean tech led to many of the problems. Every single stage of innovation, from TRL 0 to TRL 9, needs to be purposefully managed and encouraged. And the idea here is to do exactly that, to support innovation at every stage of development. The LEEP programs that were created through the Department of Energy are a critical component of that effort. And it's exciting to see many of those programs, many of those companies grow and now be supported by Breakthrough through either the Fellows Program, so Celodyne, which is building novel membranes for fuel cells to support heavy-duty trucking right in Chicago, Cement, doing electrochemical production of cement, and ClearFlame, another program in Chicago, developing an effort to transition diesel engines to run on methanol and ethanol. So the programs have been incredibly impactful, largely because of John's careful stewardship. It's wonderful to see the group of people that are assembled today, and we look forward to working with the LEEP program going forward. So thanks very much for everything you've done, John, and good luck with your retirement.
Thanks, Eric. Retirement, I don't know. It's a theory at this point. Maybe I'll put it down to practice. So what is LEEP? Well, LEEP is a game-changing model to move science into impact. The most important aspect of that is the fellowship. Getting paid full-time to work 2 years with 100% focus on maturing your innovation into a viable business is a game changer, and it's being copied, and it's tremendously successful. LEEP is also a workforce development program, motivated by the critical need for scientists who make those discoveries in the lab to also directly participate in the process of moving their innovations into impact. The likelihood of success goes way up if the scientists are directly involved. LEEP is a startup incubator at a national lab, putting the vast, unique resources the lab have, and by the way, I'm talking mostly about people, not just the toys, not just the capabilities, to work rapidly to move these innovations into viable small businesses. LEEP inspires entrepreneurial thinking in a national lab, inspiring new directions in basic research. This is a two-way street. It's a win-win for the labs and the innovators. The engine that drives that is the collaboration between the LEEP fellows and lab scientists. By the way, one of the models we have in CRI is LEEP. Our job is to make everybody uncomfortable. We push the envelope in every way. We push everybody out of their comfort zone, the innovators, the scientists, the national labs, especially DOE legal. But that's our job. That's what we do, because we're trying to drive a very big outcome. And wow, do we do that. LEEP is a 10x better, faster, and more efficient way to move science out of the lab and into the market, creating jobs and ultimately driving economic, environmental, and social impact. LEEP's metrics speak for themselves. Over 100 startups, $1 billion in follow-on funding, 1,000 jobs. You do the math, that's a 15x ROI, which is only going to get better. Full stop, nothing compares to it. LEEP is also a new engagement model between the labs and their communities. LEEP connects the national labs to the regional ecosystems in new ways, leveraging the superpowers that startups have to convene and collide key stakeholders across the entire innovation ecosystem. LEEP also fosters underrepresented groups and helps drive the fruits of basic research into underserved communities. 50% of LEEP fellows are underrepresented groups, 40% are women founders. At CRI, we used to say, and we still do, not everybody can be a great entrepreneur, but a great entrepreneur can come from anywhere. Now, context. Why is this all important? 2 words, climate change. The next energy crisis is climate change, and it is here upon us. The challenge of net zero 2050 cannot be met through the application of existing solutions. Decarbonizing whole new industries means moving new discovery science, into impact faster than we ever have before. 2050 is only 27 years away. We need what LEEP does, and we need more of it. But, perhaps the best answer to what is LEEP? People. LEEP is a community of innovators and scientists, and of course the LEEP node teams, stakeholders, who share a common passion for driving impact. The motivation for the summit in large part was to celebrate these courageous individuals who are taking the road less taken. In particular, for the graduating innovators you'll hear from today, their courage and determination in the face of COVID over the past 2 years deserves its own recognition. I cannot imagine how to make moving deep tech into the market more harder than to try to do it during a global pandemic. So we need more LEEP. Well, with that in mind, it's my pleasure to introduce Martin Keller, who is the director of the National Renewable Energy Laboratory, to tell us about a new LEEP node at NREL, Westgate.
Hello, I'm Martin Keller, Director of the National Renewable Energy Laboratory. NREL celebrates its 45th anniversary this year. In that time, as the country's premier laboratory for renewable energy and energy efficiency research, NREL has always recognized the importance of partnerships in our mission to create a clean energy future. By working with government, academia, nonprofits, and industry, we have accelerated innovation from enabling breakthroughs in basic science to de-risking and commercializing technologies and deploying them at scale. We realize the stakes are high and recognize the urgency of the challenge. It took 3 decades for solar panels to become one of the cheapest sources of electricity, but we know we must shorten this process to 10 years to meet this administration's and world's climate goals. We're incredibly excited to join the Department of Energy's Lab-Embedded Entrepreneurship Program with the 4th node at NREL named Westgate. This incubator provides a bridge between market discovery and startup creation as part of our Innovation and Entrepreneurship Center. Aligning with our history of collaboration, NREL hosts Westgate with support from our neighbors, Colorado School of Mines, the state's top science and engineering research university. We recognize there are numerous potential cleanup startups in advanced manufacturing and building efficiency just waiting for the proper resources to make a significant impact. Westgate gives innovators the time, training, and technical capabilities they need to quickly transform a promising technology into an early-stage company ready for growth. To broaden the program's talent pool, applicants are not limited to those who have doctoral degrees. Westgate will consider candidates with a bachelor's degree in the STEM field with industry or graduate experience. By putting these innovators on a path to success, Westgate helps create companies that go on to raise additional funding, hire more employees, and bolster our local economy. They may eventually partner with large industry stakeholders, work with the laboratory after the program, and even become the next major players in the industry at large. I'm very much looking forward to meeting our first cohort of talented entrepreneurs and seeing how they, along with participants across the National Lab complex, transform the clean tech industry and the globe.
Thank you so much, Martin, for sharing why LEEP is important to the NREL mission. My name is Rochelle Ely, and I am the Managing Director for the Westgate program at the National Renewable Energy Lab, or NREL for short. NREL is the premier national laboratory for DOE's energy efficiency and renewable energy missions to decarbonize sectors like electricity, transportation, buildings, and manufacturing, to name some. NREL prides itself as a living laboratory to test and validate emerging energy tech. The campus itself houses a few net zero buildings and sites through high performance building design and renewable energy integration. We are more than thrilled to welcome DOE's 4th Lab Embedded Entrepreneurship Program, or NODE, with NREL hosting the program. We are aligned with the mission of LEEP, which is to support promising technical innovators on their path to entrepreneurship and energy impact. True to the LEEP mission, Westgate is all about bridging gaps faced by early-stage entrepreneurs. Our program provides a wealth of support with over $500,000 of programmatic funding, training, and mentorship dedicated to top-notch innovators. Through a competitive selection process, we are pleased to offer an annual living stipend, a technical assistance funding redeemable at NREL and the Colorado School of Mines, as well as curated entrepreneurial training and curriculum. We recently launched this past fall and have nearly completed the selection process for the inaugural cohort, with more on that later. We're pleased to provide innovators extended access to technical expertise and capabilities. Through our program partnership with the Colorado School of Mines, Westgate innovators can leverage program resources and multi-million-dollar facilities, both at NREL and mines, over a short 2-mile distance from each campus. We appreciate the rapid prototyping capabilities mines have to offer, as well as access to talented student engineering teams. Through this partnership, innovators will be well equipped to fast-track their tech development. We are proud to announce our initial selections for our first cohort. Here with us today is Andrew Gabor to share more on his solar PV module defect detection technology. We also have Mike Konev on the line to discuss his platform for plastic and textile recycling. More recently, we are proud to select Grant Gunnison with sponsorship by the Building Technologies Office. Grant's technology tackles residential decarbonization through his retrofit software platform. Please stay tuned to our program webpage, westgate.nrel.gov, for official cohort and announcements, as well as staying tuned to our cohort 2 release. With that, I'm going to turn it over to Andrew to introduce himself.
Hey, I'm Andrew Gabor. I'm CTO and owner of Brightspot Automation. I've worked my entire career in the photovoltaics industry and actually got my start right here in this very building, Building 16, Denver West, as a graduate student working on thin film photovoltaics. So Westgate's sort of a coming home to me. It's also really exciting, an opportunity to work with some of my favorite NREL researchers and to really fill some of the holes in my own entrepreneurial education. And so after NREL, I went to Evergreen Solar. I worked there for several years. I really worked on every stage of solar cell and solar panel R&D, product development, reliability testing, manufacturing, built factories around the world. And then later on, I also helped to found another company, 1366, with Professor Ellie Sachs from MIT and Frank Van Mierlo. And it's with this insight and experience, I wanted to start my own company. I thought, what is the most impactful thing I can do? And it's really, I decided was to try to lower the levelized cost of electricity by photovoltaics. And the most important lever we have to do that is to lower the degradation rate of the panels, make them more stable, make them last longer. So at Brightspot, we have a saying, you can't fix it if you can't see it. So our company makes imaging equipment so you can see the problems in the solar cells and solar panels, things like electroluminescence, photoluminescence, and now a new technique called UV fluorescence. And UV fluorescence, or UVF, is really potentially the most impactful of these, because it can be done at very high throughput and low cost. And it allows you to see some defects that the other technologies don't let you see. A wide variety of defects like cracked solar cells, hotspot heating, finger or grid line corrosion, sealing problems, and even lets you see variations in the bill of materials from one panel to another. It just so happens to be that NREL has some in-house experience on UVF. It also has great characterization equipment, a wide array of different solar panels of different types for us to test out in the field, as well as coming through the various environmental chambers. And another important aspect of this technology making it succeed is it's such high throughput that we can't be looking at each image one by one, but you need to automate that process. And so NREL and School of Mines both have researchers who are experts in machine learning. So we need to automate this process with machine learning. And so in terms of reducing LCOE costs, it's important to have these feedback steps at every stage, from product development to certification testing to outdoor field testing. And our technology, our UVF technology, will allow better feedback to develop more robust, more durable products. It's also important that this feedback loop extend to the investors and insurers, so they can see what the better technologies are and let those rise to the top. So But at the end of Westgate, we hope to have developed 2 new UVF products, both for the lab and for outdoors, and to have 15 unique customers for our products. 5 of those we hope to have invested in our new machine learning technology. And so, one of our first hires, probably early on in the Westgate program, will be a machine learning software engineer. So if you know anybody who wants to move to sunny Colorado, please send them my way. Thank you.
Thank you so much, Andrew. We'll now turn it over to Mike Konev, our newly selected innovator.
Greetings, I'm Mihail Konev, founder of Terraform, a chemical recycling venture that produces recycled polyester resin from textile waste at a cheaper price compared to their oil-derived counterparts. So I came to found Terraform starting from a career in synthetic organic chemistry, where over the last decade I've focused on discovering and optimizing catalytic chemical reactions to build complex molecular frameworks that are relevant to natural products and pharmaceutical synthesis. When I was pursuing a related research opportunity in Germany, I became aware of how much more dedicated the EU was, both for sorting and collecting recyclable materials, as they had separate containers for all the colors of glass waste, accessible composting, and importantly for my then hobby of sampling German beers, bottle bill incentives. So this led me to consider why the US had such abysmal recycling rates as compared to the EU. As we similarly have access to pretty good resources, incentive structures, depending on the state. And of course, we understand the physical and chemical properties of the materials just as well. So this ultimately led me to pivot my career direction and leverage my ability to design catalytic reactions from making chemical bonds to breaking them in waste plastics. As I'm sure that many attendees here are aware of, mismanaging of plastics waste has truly progressed to an environmental catastrophe. So along these same lines, about 92 million metric tons of textile waste are generated every year, where about 60% of these garments and other textiles are comprised of polyester fiber, that same petroleum-derived plastic that's in drinking water bottles, known as polyethylene terephthalate, or PET for short. So not only has mismanaging of this plastic waste been a problem, but it's exacerbated by the lack of technologies that are able to transform these materials into new products. So to give you a background, the recycling rate of polyesters in the US is about 15%, but this is mostly for those same water bottles that I mentioned before, with the mature mechanical recycling that you're likely familiar with. This is contrasted with the less than 1% of textiles that are recycled into new ones. So I had the opportunity to start towards this path over the last couple of years at NREL, where along with my colleagues Kevin Sullivan and Greg Beckham, we began developing chemistries for breaking down a variety of waste materials back into their constituent molecular building blocks. So Terraform's core technology is centered on a patented protocol that we developed at NREL that breaks down polyester textiles, with our initial markets focusing on carpets. And this process uses abundant metal catalysts with oxygen and air to break down these materials into the corresponding building blocks, which we can then remake into that same virgin grade PET polymer. And we initially aim to target, as our beachhead market, 3D printing filaments, which allows for some of the local 3D printing companies and their suppliers that we've identified here in Colorado and offer them a post-consumer material at a competitive price without compromising on the physical and mechanical properties of these filaments. The Westgate program will be instrumental towards our success in closing the commercialization gaps that we're facing. And the current one is scaling. So currently we've demonstrated proof of concept on the gram scale. And by the end of Westgate, we aim to validate this on the 100-liter scale, which sort of translates to the single-digit ton per year of material processing. Westgate gives us access to world-class reactors and analytical systems, allows us to keep strong connections that we fostered with the brilliant and motivated staff here, and the development of Colorado School of Mines' new Labriola complex, which is a state-of-the-art 3D printing prototyping facility. It gives us access to learn about the intricacies of the 3D printing ecosystem. So with this assistance in this program, it'll help us de-risk the technology to help play a key role in alleviating the plastics pollution crisis that our society faces. Thank you.
Thank you so much, Mike, and thank you so much for your attention. As you're aware, we're new to the LEEP family, so thank you for the warm welcome, and please stay tuned for Cohort 1 official announcement later this summer, as well as news around Cohort 2 release. And with that, I'll hand it back over to John.
Hey, congratulations, Rochelle, the Westgate team, and the founding cohort. I had the pleasure of visiting all of you in Boulder at the finals competition, so really super exciting to see that LEEP node get off the ground. So everybody, welcome back to Chicago. Really exciting to see the new LEEP node. There's also a new LEEP node in New Mexico, not supported by DOE, but another part of the US government, based at Los Alamos National Laboratory. And we are delighted to have NW LEEP as a sponsor for the LEEP Summit. Here's a short video about that program.
We can support LEEP innovators in New Mexico by helping them to examine the materials or the devices that they're working on, understanding what goes right, what goes wrong, understanding how things function.
We can support any area where biological solutions are needed to solve complex and often difficult problems.
Los Alamos has been developing instruments and technologies for space applications for more than 50 years. We apply a variety of advanced techniques like artificial intelligence, machine learning, and advanced computing architectures to optimize the way that computing is done for these kinds of problems.
Congratulations, Lauren, Duncan, MJ, Molly, David, and Lindsay Mace for setting up the LEEP program based in New Mexico. Now it's time to kick off the Demo Day segment of the segment, where we will feature the graduating fellows from each of the 3 active nodes, as well as some of the alumni from these programs that have gone on to do big things. Let's start with, of course, my favorite LEEP node, Chain Reaction Innovations, which is based here in Chicagoland. It is my great pleasure and honor to introduce to you the new Director of Chain Reaction Innovations, Dick Coe.
Thank you. Well, good afternoon, everyone. It's so wonderful to be here virtually and in person to see colleagues, friends, old and new. But I really want to congratulate John on his retirement. I think he's going to be sick and tired of us reminding him of it, but thank you for leading CRI and LEEP with passion, integrity, and we are all grateful for your service. And it's really an honor for me to step into his shoes to be the director of CRI. But also, before we get into the program for CRI, I want to really express my deep appreciation for the people who worked so hard to make this summit a reality. First, DOE's Advanced Manufacturing Office for supporting the LEEP program from its start and also sponsoring the summit. But most importantly, the local Summit Steering Committee at Argonne, who worked tirelessly and met countless hours to make this happen, the LEEP Summit Organizing Committee that engaged the other LEEP nodes, and of course the DOE communications staff. We couldn't have done this without you. So CRI is a LEEP node that provides a 2-year fellowship and a generous research allowance for innovators to leverage the unique capabilities and expertise at Argonne to de-risk their technologies. I want to echo what John said, that innovation is mischievous. We are surrounded by innovators who are tackling problems that we didn't even know how to tackle just a few years ago. So I want to sort of relate, so that really resonated with me. So before we hear from CRI's 4th cohort, the graduating cohort that started in 2020, and 2 alumni from our 1st cohort, I want to come back to thanking our DOE sponsors for CRI and LEEP. Again, the Advanced Manufacturing Office under EERE since the inception of the program, and also this year, the Advanced Scientific Computing Research Program under the Office of Science. So thank you for that support. DOE's investment in training the next generation of energy entrepreneurs is clearly paying off, echoing what Secretary Granholm and Paul Kearns mentioned, that our innovators have gone on to raise more than $209 million in follow-on funding and created more, as of today, more than 430 jobs. CRI is also supported by Argonne, and I'm grateful for the laboratory's commitment to make a positive impact on society. So thank you, Paul, for that support. If the experiences of the past 2 years taught us anything, it is that equity and inclusion need to be part of our everyday work. In my opinion, it's frankly strategic and not altruistic. As such, building on what Paul mentioned earlier, I'm pleased to acknowledge the work that the CRI and Argonne teams have done to create a program that allows CRI to reach into the university level for talent, not just PhD founders or industry professionals. We are still in the pilot phase, but this program that we call Students for Energy and Entrepreneurial Development, SEED, SEED, will focus our work on recruiting college students at minority-serving institutions. This internship program will bring new talent, voices, and perspectives that have traditionally been left out of clean tech and climate tech. It will also provide opportunities for under-resourced students to develop their business acumen and expand their professional networks to ultimately pursue a STEM career or start their own businesses. So stay tuned as we share more about the SEED program. Okay, so now on to the entree of this program. I will now introduce the cohort 4 innovators. So first up will be Matt Ackerman, originally from Las Vegas, Nevada, and co-founder of QDIR. So Matt, turning it over to you.
Thank you, Doug. Okay, great. Well, good afternoon, everyone, and welcome. It's my pleasure to be here today. My name is Matthew Ackerman. I'm the CEO and founder of QDIR. And we're improving safety and security in the defense and commercial sectors with high-resolution infrared imaging. So we've all been here before. You're driving down a dark road late at night. You can't see what's ahead of you. You lean forward, eyes on the road, 2 hands on the wheel. You're hoping that if something comes out, you'll be able to react in time. And you feel tense because you know that you can't prevent what you cannot see. And nowhere is this feeling of uncertainty more apparent than in concerns of national defense. Blind spots that impair situational awareness can leave you vulnerable and susceptible to attack and can be the difference between life and death. And there's a growing need for the ability to see more and see better as soon as possible, regardless of day, night, or weather. The need for enhanced situational awareness demands better visibility, the ability to see under all weather conditions, improved accuracy, the ability to detect and identify potential threats, and decide how to act as soon as you can, and improved reliability, operating 24/7, 365, so you know that you're protected when you need to be, and you're never left unprepared or vulnerable. And at QDIR, we're developing the high-resolution infrared sensors for low-visibility imaging for enhanced situational awareness. We're using advanced solution process nanomaterials to make high-resolution infrared detectors for both passive thermal imaging, the detection of objects based on their temperature, and low-light active imaging. With QDIR sensors, we offer wider field of view, so you can see more. High-resolution megapixel imaging, so you get better accuracy over longer range and can react sooner. And our advanced nanomaterial platform and processes enable cost-effective sensor solutions for high-volume deployment, so you have your sensors where you need them, when you need them, and you're never left blind. So our target market opportunity is national defense, specifically addressing a need for enhanced situational awareness to protect and defend soldiers on the ground and give them the opportunity to react and proceed safely. But infrared plays a key role in society for industrial and commercial applications as well. Infrared cameras enable us to see the invisible greenhouse gases that contribute to climate change and to mitigate leaks in chemical and oil production that are making the situation worse. As well, our infrared sensors that we're developing today will be used for driver assistance and autonomous navigation. The ability to see under all visibility conditions and detect hazards on the road before an accident occurs will enhance the safety of drivers and security of future autonomous vehicles. So the core technology behind QDIR was developed and patented at the University of Chicago in 2019, and in 2020, QDIR was founded. Today, our mission is to improve safety and security with advanced infrared sensors, and we've received support from Chain Reaction Innovations for the development of our prototype technology in collaboration with Argonne National Laboratory. We received additional support from the National Science Foundation, and in 2022, we started work with a prime defense contractor and the Office of Naval Research to develop, scale, and test our high-resolution thermal sensors. In 2023, we'll continue pilot and field testing with these partners. We've assembled an expert technical team, including the co-inventors and key contributors to the core technology. We have experience in nanomaterials science, infrared sensing, and knowledge and experience on the scale and commercialization of advanced semiconductor technologies. We're seeking $1.5 million to close joint development agreements with key partners and to bring our lab prototype to a viable commercial pilot product. And today we're here seeking to talk to advisors and investors who are excited to join us and see beyond with the next generation of infrared sensors. You can find me at the booth or contact me here to learn more about how you can work with us. Thank you. Thank you, Dick.
Great. Thank you, Matt. So next up, I would like to invite up Karen Calvinho, originally from Curitiba, Brazil, and co-founder of Renew CO2. Take it away, Karen.
Hi, everyone. I'm Karen Calvinho, and I'm the CTO of Renew CO2. We're the future of carbon. As everyone knows, climate change is the challenge of our lifetime. And just in the chemical industry, 920 million tons of CO2 are released every year. Chemical companies receive demand from customer-facing brands for more sustainable products, as well as tax incentives to do better, and have committed to being carbon neutral by 2050. However, there aren't enough technologies that can produce chemicals without carbon emissions. That's where we come in. Renew CO2 is developing carbon utilization technologies that present a cost-effective solution for upgrading CO2, replacing fossil fuels for plastic raw materials. Currently, the polyester process starts with ethylene that gets oxidized and then hydrated to monoethylene glycol and polymerized with PTA to make polyester and PET. Just in the process unit of ethylene oxidation, 500 kilotons of CO2 are emitted per plant per year, which can have a very high regulatory cost. Our solution is to use that CO2 to produce up to 35% more MEG, using a high purity stream that's already there. The secret for that is our catalyst that was developed at Rutgers University by the 3 co-founders of the startup. The catalyst has no precious metals. The process is driven by electricity, and it's very energy efficient, which guarantees that it can be cost competitive to petrochemical processes. And because our solution is electrochemical, it is modular, and it can be retrofitted to existing chemical plants with minimal retooling. Our process is the only one that's carbon negative, modular, reduces the fossil fuel use, and it doesn't add any production cost, and it can become even cheaper than the petrochemical process because we're leveraging renewable electricity. To a customer, a 40 kiloton per year add-on process would cost $33 million, add $28 million of revenue every year, and allow them to get tax incentives of up to $3 million. At the same time, that process allows them to increase capacity at the same pace as the market is growing, without reducing the risk for capital investments. Our business model is on the sales of modules, process engineering, startup services, and technical support for these processes. And we want to get recurring revenue as well from a royalty on tax credits. The market for this is very large. There are $43 billion in capital equipment for MEG production, and that market is growing by $2 billion every year. Our go-to-market strategy is to sell these processes directly to chemical companies, and we already have existing contacts with more than 20% of them. Our team has more than 50 years of experience in catalyst development, as well as wide experience in the chemical industry, especially in bringing new processes to work. And so far, we have raised $2.3 million in non-dilutive funding with support from DOE, NASA, and NSF. Thank you so much. And that has allowed us to demonstrate the process at lab scale, translating it from a batch to a continuous process. We also have received letters of support from potential customers indicating their interest in seeing this process coming to scale. We just raised $2 million seed round and more non-dilutive funding that is allowing us to grow our team. And we're working on that right now, as well as securing industry partnerships to reach our milestone of demonstrating a pilot process by next year. Next, we'll go to commercial scale, and we want your support and really helping us to get the people that we need to get this process off the ground, and getting partnerships to enable this technology to reach market fast. Thank you so much.
Thank you, Karen. And next up, I would like to invite up Pranav Gokhale, originally from Germantown, Maryland, and co-founder of Super.tech. And his technology, as Juan de Pablo mentioned, started right here in Hyde Park. So Pranav, take it away.
Thanks so much. Hey everyone, my name is Pranav Gokhale, and good afternoon. I was the co-founder and CEO of Super.tech, and our mission has been to accelerate quantum computing, which is a technology that's going to transform what humanity can compute and solve. And the reason I use past tense is that, just fresh off the press, we were recently acquired by Cold Quanta, which is a company based in Colorado. Now this is the Chicago office, and they are the leaders in cold atom technology. But I want to tell you about what we accomplished in the last 2 years with Chain Reaction Innovations, which was the way that we founded our company. So the core thesis behind Super.tech was that there are inefficiencies in quantum software that can be leveraged. And in particular, the top of the software stack for quantum computers is very digital. It's zeros and ones and very binary programming. But the reality of quantum hardware is that it's actually analog. It's these hardware control pulses on the bottom right. What we developed is a software technology called SuperStack, which goes directly from the top of the stack, where you have the end user applications of quantum, to the bottom of the stack, which is the actual quantum chip. And by making this translation as direct as possible, we enable optimization across the different layers of the stack. And ultimately, the value proposition here is that we enable hardware to be accelerated by 5 years worth of progress, but done virtually through software. And in fact, Cold Quanta was originally one of our customers that was using our software stack to accelerate the performance of their quantum computer. Now, I could drone on about the IP underlying our software and our technology, but I'll just mention, as Juan de Pablo said, that it was developed at the University of Chicago and further validated and enhanced through Chain Reaction Innovations. What I want to tell you about is how we took this technology to market. We launched a software product called SuperStack, which is our cloud software offering. And what it does is it enables customers to take software from any input source language, including our open source front ends, and target any hardware from vendors like Cold Quanta, Honeywell, IBM, Rigetti, et cetera. And this has enabled us to reduce the barrier to entry to people who are exploring quantum hardware. In addition, we developed very application-centric APIs so that, for example, you can explore the traveling salesperson problem and potential speedups on a quantum computer without needing to integrate Schrödinger's wave equation. Similarly, we have APIs in finance with partners like Morningstar and customers that are going to be announced soon in the banking world that are using SuperStack to optimize their portfolios. Finally, in the energy space, we have a longstanding partnership with Exelon, the nation's largest utility company, and they've published papers with us, and they've used SuperStack to prototype solutions from quantum computers for problems like load forecasting and unit commitment. We launched SuperStack at the 1-year halfway mark of chain reaction innovations, and our early adopters included big companies like Morningstar, as well as national labs like, of course, Argonne, as well as Berkeley Lab. And one of our first paying customers was Berkeley Lab. What I really like about how they're using SuperStack is that they actually submit jobs to SuperStack whenever they run optimized circuits on their hardware. And we just have a paper that came out with them yesterday demonstrating an 80% advantage using SuperStack. We also recently launched SuperMark, which is our benchmarking platform, and it comes from an understanding that customers want to understand where quantum is today and whether it will solve their problems in combinatorial optimization, chemistry, and sensing. And we've run different jobs on every hardware out there. This has received coverage from Amazon Web Services, from BCG, and consulting agencies like Protiviti. In the span of our 2 years, from launch to acquisition, we raised over $3 million in non-dilutive grants and revenue, with a lot of advising from Chain Reaction Innovations, and we launched proof of concepts with several companies, including Cold Quanta. This is the team that made this all happen. My co-founder was Professor Fred Chung at the University of Chicago, who's now the chief scientist at Cold Quanta for quantum software. And while I often get the media spotlight, the people doing the real hard work on weekends and evenings were the folks on the right-hand side. So I want to express my gratitude towards them. And the whole team has now moved to Cold Quanta. So in summary, this is what we did over the last 2 years. We launched a software stack that will close the gap from applications to quantum hardware. We got user traction, and we were very lucky to have unfair advantages through our premier partners, foremost at this event, Chain Reaction Innovations. For those who are sticking around in person, feel free to come chat with me at the booth. And we also happen to be headquartered in this building 2 floors below. So if you want to meet the rest of the team, feel free to head down there. Thank you all.
Thank you, Pranav. It's my pleasure to invite the next innovator up, Margaret Kocherga, originally from Kyiv, Ukraine, and founder of Margik. Here you go.
Thank you, Dick. I'm a founder and CEO of Margik, and today we'll talk about light-emitting devices. And I would like to start out with the problems of light-emitting devices of today. They're damaging for our eyes. They kill retinal cells in our eye, as well as they cause fatigue. They also result in emissions of CO2, which are equivalent of 500,000 driving cars. Also, 70% of all global waste contains some form of lighting within it. And current devices are including heavy metals in them, which tend to absorb through the soil and end up in our food chain. So where do we move from here? That's where exactly the problem is. USA is facing a pivotal point in need of geopolitically independent production, and it must be solved in a cost-effective and sustainable way. Our current supplies come from countries such as China, Australia, and Russia. Electronics industry will be an over $1 trillion of revenue by year 2040, but by that same year we'll run out of most of the elements that are necessary for production of the LEDs. What's the solution, you may ask? Well, the solution is to move to organic LEDs, which we have been in the last couple of decades, because they are capable of utilizing earth-abundant and locally available materials. They can be cost-effective in the future, and these devices also have potential for recyclability as well as being biodegradable. But the problem of today's organic LEDs is the complex manufacturing, and which results in extremely high-cost devices. So what Margik's vision is to be world's first low-cost, high-volume organic LED platform. These platform materials can be applicable not only in lighting, but also in solar, packaging, windows, and even drug discovery industries. Margik's solution enabled 23% power reduction for the light devices used, as well as 11% brightness increase. Margik's patent-pending technologies also enable 80% faster manufacturing processes, as well as 66% reduction of CO2 emissions. Our competition, you may question this, is very large companies, and we understand that. But when we performed our customer discovery and looked at a market for the last couple of years, we realized that there are gaps on the market that our customers voicing, and Margik has the exactly right solution to fill in those gaps. The market size composes from several industries, actually. We're not only combining material science industry, but we're also combining organic LEDs as well as packaging industry all together in order to achieve the product that we're going to launch very soon. Margik is aiming at $10 billion of revenue by year 2030 based on these products. Our early market entry is through branding and packaging, light up branding and packaging. So if you're here today, you're welcome to come see our demo bottle as well as some business cards to demonstrate this, which would bring us revenue very soon by beginning of next year. Our team has 90 years of consumer electronics experience, including some of the global leaders such as Samsung, Kodak, and DuPont. And we have also technical expertise in the heavy metals toxicity, hybrid electronics materials, as well as LED and display engineering. Our team also includes advisors with supply chain experience, specifically in the electronics industry, and also repeat founders with 3 successful exits. Our current achievements today, we have raised $1.2 million from government contracts, accelerators, as well as private capital. We have 5 layers of support for technology that we are producing from medium-sized companies. And we also have 2 intents of purchase from manufacturers of lighting devices. Next, we'll scale up from niche and luxury items into lighting and solar and smart window industries, which would lay the groundwork to ultimately enter consumer electronics industry and reach that $10 billion mark. What's next for us? We're looking to close some early customers from pharmaceutical and bottling industry, so if you have referrals, please send them our way. We're scaling our USA-based manufacturing facility, and we're ready to launch on the market with the packaging materials. A total ask today from you is $1 million. So if you know somebody who is ready to invest, we welcome you to add on to our investor pool as well. Please contact me at info@margik.tech, and let's hope to talk to you. Thank you.
Thank you, Margaret. Thank you. Our next innovator is Chris Pasolano, originally from New Lenox, Illinois, and co-founder of SiMat EnerTech. Here you go, Chris.
Thank you very much. Hello, my name is Chris Pasolano. I'd like to introduce you to SiMat EnerTech. Today we would like to present to you our silicon-based rechargeable batteries for high energy, high power, and long cycle lifetime applications. In our warming world, not only do we need cleaner energy generation methods, but we also need better energy storage. Our current carbon anode technology, unfortunately, does not meet the energy storage needs of our current consumer electronics. It is imperative that we find something better. At SiMat, we believe we found this in silicon. As a lithium anode, silicon has a theoretical capacity of over 10 times a carbon anode. However, this comes at a major cost. Upon lithiation, a silicon anode will shrink and swell to the point where after a dozen cycles or so, the battery is completely useless. Current silicon-based anode technology utilizes what's called a yolk shell structure, where you create a bulky void within a rigid shell to allow for this expansion without any ruptures. This has potential, but is not very efficient right now. But that's where we come in. With our patented nanochannel voids, we can create a silicon battery that operates at higher capacities, higher energy, and faster charge rates than our silicon competitors. Additionally, our material is able to be manufactured using environmentally friendly products that anyone can handle and creates byproducts that are safe to be recycled immediately. And finally, after 1,000 cycles in our half cells, we've seen that our anodes do not have any physical degradation, meaning they don't shrink or swell like our other competitors do. So what that means for us is we can have a fully charged silicon anode in 3 to 6 minutes. We can operate at a current density of 1 amp per gram, and we see almost zero capacity decay after the first 700 cycles of charge. Compared to carbon, this is a massive advantage. We can operate at specific capacities over 3 times carbon. We have a 4 times charge rate increase over carbon. We're projected to be half the manufacturing cost of a carbon anode, and we operate at a 30% higher energy per unit mass than carbon. What this translates to is each cell operates 43% more efficiently at 70% the cost. So as we look forward to our potential market, we know we're entering a crowded marketplace. Not only are we competing against tried and true manufacturers such as LG Chem and Samsung, but we are also entering a very crowded silicon space consisting of amprius and nanograph technologies. However, we know that our nanochannel voids will provide us the edge we need to succeed. As we look forward to our market, we've identified the electric vehicle industry as our beachhead market, which is currently a $600 billion market. As a follow-up market, we've also identified vertical takeoff and landing, urban air mobility, and commercial drones, a $400 billion market, as a quick add-on. And within these markets, we've also discussed with Ford and Volkswagen as potential pilot partners, along with Uber Elevate and FlyMotion in the drone sector. So where are we currently at? We are currently at a tech readiness level of 4. We have produced lab scale manufacturing cells and are looking to scale up to a full pilot test cell. Within these goals, we've also identified as increasing our specific capacity to 1,000 milliamp hours per gram. We would like to reduce our capacity decay to less than 20% to match current technology advancements. And we'd also like to translate our full coin cells into pouch cells that could be a drag and drop solution for the current EV industry. Our target goal is to make cells using existing infrastructure, so there's little change to the supply chain. And thanks to CRI through Argonne, we think we're closer than ever to achieving this goal. Currently, we are looking to fundraise $5 million. This $5 million will go towards helping us to construct a semi-autonomous manufacturing hub here in Chicago. We would like to also grow our team from 2 to 8 members, including employees, leadership, and mentorship. And we'd also like to explore licensing agreements with companies such as LG Chem and Samsung to help provide us the runway we need to continue researching advanced materials so that we can continue improving on our batteries. And with that, I'd like to introduce you to our team. It consists of our founder and interim CEO, Dr. Leon Shaw, and myself, Chris Possolano. And if you'd like to hear more from us, please reach out to me at the booth, or you can email me at cpossolano@SiMat EnerTech.com. Thank you very much.
Thank you, Chris. Next up is Carol Scarlett, originally from Jacksonville, Florida, and founder of Axion Technologies. Here, Carol.
Thank you. Good afternoon, everyone. Hi, I'm Dr. Carol Scarlett, CEO and founder of Axion Technologies. And I want to tell you a little bit about my company, which is a hardware company designed to develop quantum random number generators. And through chain reactions innovations, we're looking to turn those into chips. But let me just say a few words. First, everyone is probably very familiar with the use of deterministic computing. This is the vast majority of your ones and zeros and very well-known structures. But did you know that a lot of modern computing applications depend heavily on randomness? In fact, you need randomness in everything from simulating data to artificial intelligence. And the biggest application of randomness, of course, is encryption. This is how we secure data, how we're able to mask information. That said, ironically enough, we only have poor workarounds for the most part. For the most part, we're still using pseudo-random number generators. That's your algorithms. To do hardware random number generators, you can go to true random, and for true randoms, you need quantum mechanics. So, in fact, the use of quantum computing, which is slated to revolutionize computing in general, is going to turn the encryption market and the quantum encryption market to about a $7.2 billion market in the next few years. And this is where my company comes in. We're Axion Technologies. We're a hardware company. We develop quantum random number generators, and we start with large-scale computing. How do we do this? So we do this by using photon beams, and we get the photons to random walk. We used to apply the photons to a number of layers, and they begin to random walk. And in that process, we're able to generate random intensity fluctuations, and we can extract that and use this for quantum randomness. We boast that we can do this better, cheaper, faster, because we can do this in parallel, which is something that a lot of our competitors can't. Currently, we hold several patents on our core technology, and we have several patents that are pending. I'll show you a list at the end. Our beachhead market is HPCs. These are those massive computers, those high-performance computers, rows and rows that you may have caught a glimpse of earlier in one of the presentations. There are HPCs in national laboratories. In fact, Argonne just recently received a multi-million node HPC. They're also in a number of universities. These are your large-scale computer clusters. This is our beachhead because most of the design random number generators simply are not suitable for their needs. Eventually, however, we would like to go into designing more for artificial intelligence as parallel AI is starting to grow and starting to become an emerging market. And then finally, we'd like to go into the biggest market. This is the encryption market. Of course, getting into these markets, as you've seen from a number of talks earlier, getting in them sometimes means competing with large companies. So for the biggest market of encryption, you have the Intels, you have the SanDisks, you have the RSAs. But most of them are still doing pseudo-random number generators. They're running algorithms in order to generate random numbers. And the drawback of that is that eventually they will cycle back over the same set of numbers. They will repeat. There are a few companies like mine that are doing quantum random number generators, as you can see here. But our advantage as Axion Technologies is that we can do speed and parallelism, which allows us to supply randomness for these HPC devices and possibly for novel computing applications and communication applications in a way that our customers have not designed for. When I came to chain reactions innovation as part of cohort 4, I was looking to take our larger scale device, which we had prototyped and been testing, and to scale it down to a chip. And the reason we want to make a chip, of course, is that that would allow us to go into everything. We could go into the Internet of Things and phones and your laptop computers and such. And through chain reactions innovation, we've done a lot of the work to de-risk development of quantum randomness on a chip. We've looked at 2 different possibilities, including integrated photonics and multi-layered 3-dimensional chips. As a company, we have raised over $1 million in non-dilutive funding, and we continue to get and look for grants, but at the same time, we are looking to do a funding raise because we want to grow our company. We have a number of verticals we want to get into the market. We're looking to raise between $1 and $1.5 million in order to expand our team and in order to continue marketing our products. In addition to quantum random number generators, we also make hardware technologies for computer networking and communications. You see here that optical splitting and multiplexing are both multi-billion-dollar markets. I'll just say that, as I mentioned earlier, we have a number of patents and patents pending. So as a company, we own all of our own technology. We have a small team, but we'd like to grow it. And finally, if you're interested in really unique technology, something really novel, please come by and see me at the booth. Thank you.
Great. Thank you, Carol. And that concludes the pitches from our 4th cohort. And next, I would like to invite up some of our alumni from our 1st cohort. First up is Justin Whiteley from Meatyfoods, and thanks for coming from Colorado.
Thank you. So, Justin Whiteley, CTO and co-founder of Meatyfoods. We were part of CRI cohort number 1. Extremely grateful to that program for helping us get our start. So at Meati, we are democratizing nutrition. Our mission is to feed everyone forever. I know, big, audacious goal, but we believe we're on our way. And we do this by harnessing the power of mycelium, which can be thought as the muscular root structure of mushrooms. We bring our product to life with this nutrient-dense composition that is good for consumers and the planet. We are addressing a critical market need in the vastly expanding market segment of alternative meats. And let's be real, current alternative meats just aren't cutting it. They have lengthy ingredient lists that give off the perception of processed foods and being unhealthy. They struggle to compete on price with animal meats, and most alternative meats are only in the ground form. However, if you look at the US meat market, even last year, over 60% of this market was in the form of whole cut options. That would be your chicken breast, your steak, your pork chops, and so on. So nutrition, price, and texture all lacking in current alternative meat options. And this is where Meati comes in. We have inherent advantages. Really, Meati is built on texture. By aligning the natural fibers found in mushroom root, we can bring to life our whole cut alternative meat products. By diving into our nutrition label, Meati is really one of the most complete foods derived to date, with low fat, no sugar, fiber, and all the protein you might find in animal meat. And exploring these micronutrients even further, you find most of your daily vitamin Bs and more iron and zinc than animal beef. Really, what we're looking at is an amalgamation of meat and vegetables. And these products have been validated by some of the most prominent thought leaders in the space, including investors and chefs such as David Chang, Tom Colicchio, food legends such as founder and former CEO of Whole Foods, Walter Robb, and board member and sustainability advisor, former CEO of Patagonia, Rose Macario, all dedicated to the mission of transforming the food industry with our sustainable food. And what do I mean by sustainable? Well, we are a vertically integrated manufacturing process where we use a few simple ingredients to cultivate our mushroom roots in a super efficient fermentation process. We build facilities like this one, our mega ranch out in Colorado, capable of making millions of pounds of Meati per year. Just let the picture sink in. A lot of work has been going into this. And it's been a long journey. You know, when we were in CRI, we were working at the lab scale, and now we're building out large facilities. So it's been a fun journey. Sometimes it takes my breath away. But really what this comes down to in the end, we estimate that our process, even inclusive of all the inputs, will be 10 times more land efficient, 4 times more water efficient than even soy protein products of a similar vein. To execute on these goals, we put together this leadership team of industry veterans with experience of building and operating large food manufacturing facilities, and also managing some of the most complex food supply chains in the world. Everyone here bought into the mission, again, democratizing nutrition. So with that, I want to thank CRI for everything they've done with us and having us back out here. Since we left in 2019, we've created over 200 new jobs. And for all of you that are going to be here at the reception, we're excited to share the Meati Nashville hot chicken sandwich with you. So thank you all.
Thank you, Justin. And last piece for CRI, I would like to invite up BJ Johnson from ClearFlame Engines to tell us more about his start, cohort 1. Thank you, BJ.
All right, so good afternoon, everyone. My name is BJ Johnson, co-founder and CEO of ClearFlame Engine Technologies. I was also in the first cohort with Justin, and I'm excited to be back here today talking about what we've been doing with ClearFlame since we left CRI. So our mission is to do something about the diesel problem. This is an engine that is at the heart of many industrial applications around the world. And at ClearFlame, we believe that we can disrupt that market by offering a cleaner and lower cost solution that doesn't fundamentally change the way that users have to get their jobs done. Now, why is this important? First off, you've probably heard a lot about the EV revolution and hydrogen coming, the expansion of natural gas into transportation. All these things are true. I'm about as bullish on EVs as anyone, but there are applications out there that are fundamentally hard to electrify. And heavy trucks are a perfectly good example of this. You've probably all seen the curves of displacement of diesel by EV and hydrogen going forward 10, 15, 20 years. But when you look at the overall displacement in that market, diesel's being displaced slower than the actual market is growing, which means we're producing more and more diesel trucks every year. And to be clear, even if we could turn this off at 2035, which we can't, these assets are going to be around 10, 15, 20 years after they're produced. So this is a massive business opportunity. There aren't a lot of startup companies that are trying to do something about the liquid-fueled, hard-to-electrify parts of the market, but it's also a massive environmental problem. The UN has already said that our 1.5 degrees C climate targets are slipping out of reach. And if Justin gets to make a let's be real statement, I will too. This is not going to happen. We need to start thinking about what comes next. How do we actually limit warming to significantly below 2 degrees C? And the only way we do that is by asking ourselves, what technologies can we deploy today to start doing something about the climate problem and bending carbon emissions back in the right direction? So I have a video today with my co-founder Julie in it that we should be able to use to show you the solution that ClearFlame has developed to this problem.
At ClearFlame Engine Technologies, we're breaking the bond between the diesel engine and its fuel to accelerate a low-cost path to a clean and equitable future.
The ClearFlame technology can be used anywhere a diesel engine is used today, but we're focused on those heavy-duty markets that don't have a great alternative to liquid combustion, like freight transportation, power generation, construction, and agriculture. ClearFlame uses low-carbon fuels like ethanol that are already widely produced and distributed into the market. That allows us to achieve the low cost and scalable benefits that regulators need to meet their carbon mitigation goals. ClearFlame can speed the rate of adoption of our technology by leveraging existing manufacturing processes, refueling infrastructure that already exists, and maintenance expertise that many fleets already have on their teams.
We provide the fastest path for scalable emissions reductions in the heavy-duty industry. I'm standing in front of our very first prototype truck. Less than a year ago, we decided that in order to show the world what this technology can do, we needed to demonstrate it in a Class 8 truck. And that's exactly what we've done. The truck behind me runs on 100% renewable alcohol fuel. We always knew that our results would translate into a vehicle platform, but now we can show the world in a package that is irrefutable. This represents a huge leap forward in showing the world what this technology can do.
So the second truck was significantly better looking than the first, and we actually hope to have it here today at the event. Unfortunately, the actual customer interest in our product has been so great, we actually have that out there in pilot demonstrations as we speak, and that's not the only vertical we're looking at. We used investment from Breakthrough Energy Ventures to advance that truck product, but we also have investment from John Deere that is allowing us to expand into off-road applications and have a wide range of pilots set up with utilities this summer, including Exelon and Duke Energy, to support the expansion of renewable electricity with on-demand diesel-style generation, but without the need for any diesel fuel. And this technology could not be more of a right technology, right time story. We have diesel fuel over $5.70 in many parts of the country. This is not only cost competitive against where diesel has been historically, it's also fundamentally lower in carbon than where an EV stands today. And I really do believe that we need a diverse range of solutions, and ClearFlame is going to be an important part of complementing electrification and expanding into heavy-duty markets. So we're raising a Series B right now. I'd be happy to answer any questions on the interest in that. And I'd also love to talk more about how we can take the work we've started at Argonne with DOE funding and really show that we can grow this to complement all the good things the administration in our country is doing around the non-combustion assets as well. So thank you. My name is BJ with ClearFlame, and looking forward to the rest of the event.
So we're going to do a short break, and then we'll be back in a few minutes, not long, to continue the great show. So see you in a few minutes.